Yes, thank you very much, my friend. Obrigado. Yes, so I have been, although it was not always called data science, I've been working with data analysis for almost 30 years now. I even started using the internet in the late 80s, and I've been programming that entire time as well. So I've seen a lot of changes, but maybe today's story is also about how some things have remained the same. It's an honor to talk to you today. I've actually even been to São Paulo, and I had a wonderful time there, and it's an honor to talk with people from such a wonderful country. I really enjoyed it, and there was a lot of energy. So today I'll be talking about the Data Science Toolbox. Can everyone see my screen now? Is it being shared?
Yes, I'm able to see it.
Oh, good. Wonderful. Well, we have just a small amount of time today, and it's a very big subject. So there's a lot of different topics, a lot of different tools. So I'll try to get to the point by putting things into context, and then I'll talk about some ways about thinking about data science tools to give you some guidance. Firstly, just to put things into context, it's perhaps not necessary to say that data is exploding across the globe. And this is being driven, for those of you who have an engineering background, partially by what's called Moore's Law, which is the notion that every 18 months computing processing power doubles. And this is historically held up such that the computers I started using in 1985 compared to now, the computers are about 25,000 times as powerful. So we're all carrying around supercomputers that in 1985 only a few banks or governments could hope to even own something on that scale. So there's this amazing explosion of processing power. We're also seeing, of course, this explosion of data coming from the web and people creating data and sharing it through the web, such that in 60 seconds we just see literally millions of posts and many terabytes of content just streaming across the globe. And increasingly we are seeing other trends emerging, such as the Internet of Things and devices that have sensors attached to them, which are both consuming and generating data, and sometimes have intelligent systems attached to them. And we're also seeing a second revival of what has in the past been called artificial intelligence, and may perhaps be better called expert systems, but we're seeing some very real innovations such as IBM's Watson and intelligent systems that can interact with people emerging. So in essence, all this has made what has been called the sexiest job of the 21st century, that the world needs more data scientists. And these people are people who combine both quantitative skills and also computational skills, and are also very creative in the ways that they think about and deal with data. So with that as an introduction, what I'd like to do is talk a little bit more about the tools. Now, I could easily talk for hours about tool sets and then the application of different data analysis tools, but it's perhaps good to begin by saying that data analytics or data science has been classified at a very high level in three major categories in terms of the methods applied, and those are descriptive methods, which is typically associated with what has in the past been called business intelligence, which is looking at things in the past. Predictive analytics, which are examining trends, and this can be associated with econometrics, but also machine learning and also financial analysis and time series analysis, and prescriptive analytics, which is usually associated with operations research and sometimes called management science, and it's ways of optimizing systems and making them more efficient. Traditionally, this has been applied to manufacturing and supply chain management, such as ways to optimize shipping and optimize factory utilization. But now these methods are also being applied in other areas, such as finance and customer analytics. So these are three of the main trends. BI, econometrics, and operations management act as somewhat of a foundation for data science. Now, underneath these are many different methods. So there's both methods for managing data, for discovering patterns, or what's called unsupervised analytics, for predictive analytics, or supervised analytics. And there's other specialty areas such as semantic analytics, which encompasses text mining, audio mining, network analysis, and then, as I mentioned, the operations research. So again, this is a very large topic that we won't be able to go into depth on today. And the types of technologies help you drive each of these methods is quite vast. So here you see a list that I will not have time to go through in detail, but you can see that there's just many different tools available to drive different applications and different methods that are applied in data science. Some of them are more associated with classical statistics, some are support machine learning. For those of you just getting started with data science, you may get the impression that machine learning is data science. That's not the case. That there's a much broader world of different techniques and tools out there. So machine learning is one application in a very broad forest of tools and techniques. So in order to make our time valuable and give you some honest guidance, I think it's useful just to say that data science is not just a set of tools. It is the combination of these tools or technologies in a process that is managed by people. So for data science, that means the combination of data engineering, data analysis, in order to drive decision making. So if you think about it from that perspective, I think we will be able to make some progress, and I can give you some good advice about tools and how you can pick your tools. So we can think of data science as being a process of driving decisions from data, and that the larger context is in businesses, at least. And by business, I can say also we can encompass organizations, so that can be also government or private and public work, but that there's an organizational aspect to that surrounds data science. And that if we think about that as a process, it's driving from the very beginning, framing problems, gathering data, building models, implementing and applying those models and methods, interpreting the results, communicating results, implementing decisions, and then maintaining models. And so this is the perspective that is supported by Informs, which is the largest global organization for data analytics, and there's a certification program. And so if you want to progress in the field of data science, I can recommend taking a look at the certification program that you can study for online, and they have videos to help you to understand what is data analytics, what is data science. So when we talk about the tools then, I can give you two particular references that will give you a great start in selecting the tools to use and understanding how they can be applied. So these are two free publications from O'Reilly. O'Reilly has long been known as a publisher of technical books, and as far back as the very beginning of the internet. And O'Reilly put out these 2 free books that are also available by PDF online. One is called the Data Science Salary Survey, and the other is called Analyzing the Analyzers, which is about studying who are data scientists and where is this trend as a profession developing. So there's a great deal of material, and it also covers tools and the application of tools. So earlier we talked about this sexiest job of the 21st century, the data scientist, and it's, I think, being increasingly admitted that the person who has all these skills is somewhat of a unicorn. I have a great deal of experience, but I have myself that there's areas I just don't have sufficient expertise on, and I'm aware of them, but it's not possible for a single person to be an expert in all the different tools and methods encompassed by data science. So what the O'Reilly books, or these publications, have done is they've interviewed data scientists and professionals working in data analytics in order to understand what their jobs are and what they do for work. So a lot of the people who responded to the surveys identified themselves as analysts, some as statisticians, some as software developers, some as managers, some as database administrators. So there's not a one-size-fits-all in terms of job descriptions or functional roles that people have when they claim to be a data analytics or data science professional. But what the researchers did do is they used cluster analysis, which is a data analytics technique, an unsupervised technique, to try to see if there are patterns or clusters that they could identify amongst the survey respondents. And so they developed 4 particular clusters, which were what they call data developers. So these are people with an engineering background and software development background. People who are considered data researchers, and these were people perhaps with a science background, perhaps in physics or even in biology, who have deep statistical, mathematical knowledge and have some basis in research, so perhaps also PhD level with exposure to formal research practices. Then they also identified data creatives. These are people who are more using computers as tools to explore data and are very creative in that application, and they're looking for patterns and visualizing data. And I've worked with some of these people, and they can be considered very creative. And then finally, a data business person, which is someone who's more considered a manager or a project leader or a technical leader. So these are the 4 categories that were identified, and the research also pointed out that the skill sets of each of these 4 clusters are quite different in terms of their emphasis, that some of these categories have more business skills, some more experience with machine learning and big data, some more with mathematics and even operations research, some more with programming, and some with statistics. So, of course, the data developer has a lot more experience with machine learning and programming. The data researcher has a whole lot of experience with formal statistics and econometrics, regression analysis, perhaps a little less with machine learning, but also a certain amount there, less programming. So it's appropriate to say that a data scientist is not a one-size-fits-all, that people have different backgrounds, and they have different functional roles in the organizations they're working in, and that will affect your decision in terms of what tools you choose. So obviously someone who's more doing applied statistical analysis will choose different tools than someone who's doing a lot of visualization, for instance, or who is using exclusively machine learning techniques. So when we put these people together, they do drive typically a process, and typically the larger the organization, the more specialization there is in the different rules, and the more people are involved in driving the process. For those of you in smaller organizations, you may be asked to do all of these things in some capacity. And if you're just starting out as someone who's learning about data science, you may want to get exposure to a lot of the different roles in order to decide what you like the best. So it's appropriate to say that it also depends on the scale of the organization and challenges that you're using with and how long you've been working with data science in terms of this process. So let's get down to the tools. So we've all heard about Hadoop. I'm sure that there's people here who are working actively with Hadoop, and you know it's quite a revolution and is driving this explosion of big data storage and analysis. That said, relational database management systems are not going to disappear anytime soon. They still drive most of the big systems. And so people who work with Oracle or SQL Server or MySQL still do quite a lot of work with data analysis, and Hadoop is used more for unstructured data storage and retrieval and an analysis, but the Hadoop platform is evolving very rapidly. So we are seeing that a number of professionals are using both Hadoop and database management systems, particularly those people who want to stay on the cutting edge. Indeed, a lot of corporations now are developing data lakes that are hybrids of traditional relational database management environments with Hadoop, and that organizations are realizing that they can use both and indeed should use both. So that may be a consideration, is that to get some exposure to structured databases and also understand Hadoop and use that as a tool. So this is a good slide, and again, this is from the 2014 Data Science Salary Survey. This is the most used toolkit according to the research here. So this list gives you the most frequently used data science tools. So of course, Windows is a huge platform. SQL, very important, so the understanding the SQL syntax in order to pull structured data out of databases is essential. Excel, so you know, as data scientists may think that that's very backwards, but Excel is not going anywhere. And indeed, I regularly have projects where the data will be presented to me in an Excel format, and I've even had unpleasant projects where I've spent, you know, many hours having to extract data out of Excel or clean it up in Excel. So it's not going anywhere. It's still a hugely used tool. R. Now, you've likely all heard about R. It's an open source statistical and machine learning analysis platform, which is a scripting environment, very powerful, growing very rapidly. It has many adherents, has the advantage of being free. It's used, I speak a lot at universities, and it's used at many universities to teach data analytics and data science. And part of the reason is it's just very easy to get started using it, which is within 30 seconds you can install it and start running scripts. So we won't have time to go through each one of these in turn, but you can see here this gives a representation of these most frequently used tools, and they're not all the same. They can be used for different purposes. So some of these are more oriented towards data storage and extraction, some more towards visualization, some are programming tools, and some are statistical analysis tools. Now, it's important to say that the research also pointed out that the majority of people working as data scientists or data analytics professionals were using upwards of 6 to 10 of those tools that we just covered. So the typical data scientist will not specialize in one single tool, but they will combine several tools. So for instance, combining SQL with R, and then perhaps using Tableau for visualization. So it's very common that people will combine tools together, and that they don't focus on one tool, but they use a range of tools, and that's very similar to myself. So we're coming a bit to a close here, and I think the last thing to mention is that also the O'Reilly research pointed out they also ran cluster analysis on the tools that were being used by these professionals, and they found 5 different clusters of tools. So this is very, very interesting, and I think is a nice conclusion for the short talk, but I hope will be hope an interesting talk. But these 5 clusters point out that the professionals fell into 5 categories, and so the first one could be called the category of enterprise data scientists. So you see here that there's tools including relational database, Windows, some of the Windows tools like Visual Basic, SAS, who I work for, and Business Objects, which was acquired by SAP, the ERP company, SPSS, which is IBM, Oracle. These are all tools that are very powerful, but they're also typically, their license fees are quite costly. So they're typically applied by large enterprises or organizations or governments. So this cluster would be people who are working in large organizations, often in large teams to drive data science as a process. So this next cluster, cluster 2, we see here some familiar names for those working with the Apache Hadoop ecosystem. We have here Cassandra, Apache Hadoop Pig, Spark, Cassandra, MapReduce, and we also see Amazon tools. So there's Amazon Redshift. We see Java. So these are people who are working more particularly with the Hadoop ecosystem and are doing big data analytics. So they may be even using many hundreds of terabytes or even petabytes of information and doing analytics on very large data sets using the Hadoop platform. So cluster 3, then we see here R, which I mentioned earlier, and Python, which is a very powerful more programming-oriented scripting environment, which is very powerful for data analytics. MATLAB, which is a commercial tool more used by engineers, and we see several other tools here. But these people can be considered perhaps the open source advocates who are using and statisticians and scientists. So these people likely are using these tools perhaps in an academic or research environment, and there's an emphasis, I would say, on Python and R. So cluster 4 then, here, this group of people, we can see here some familiar things. This cluster would be called the web platform or web-based analytics group, and these people are using, they are very dedicated to the Mac platform, Macintosh. They use JavaScript, MySQL, and they're typically developing for the web through web interfaces, so they may be using D3 here for visualization, using Google chart tools. And so this is perhaps can be called the online data science cluster. And finally, the last cluster, and perhaps I'm not yet old enough, but this may be the old men of the of the computing world. So these are people who may have been working with computers for 40 years, and they have a long beard, and they use Unix, C++, Perl, and C. Very powerful tools, and if you're an expert in these tools, you can, of course, do some very interesting things with data. But typically, these people have been working with computers for many, many years, and these are the tools they've developed expertise in. So Well, of course, and this is my last slide because I'm just about at over time. And of course, I work for SAS, and I've been very happy working for SAS. Previously, I was with Deloitte, and I had been working closely with SAS. And I noticed that whenever I was doing research on best practices, I typically finally got to a book from SAS. SAS has many, many books on data science and data analytics on just about any of the major techniques, whether it be, for instance, cluster analysis or predictive analytics. There seems to be a book out there that's been published by SAS. They put a lot of energy and time into thought leadership and research on data science and data analytics. And indeed, their tool set covers the whole range of the data science process. So they have tools for every aspect of data science and data analytics. And I can recommend them. If you're a student, you can also get access through the SAS University. And increasingly, SAS is making available tools in the cloud. So they're moving also to develop cloud-based solutions. So with that, I think I'll bring things to a close. It's a very broad topic, and I thank you for your attention. And I hope I've been able to offer you some guidance in a very short amount of time. This is somewhat of a challenge, but that is it. And I thank you for your time.